Hello, this is Ms. Wynn, and this video is about solving equations. So equations consist of two expressions with an equal sign between them. If there's a variable involved, it could be solved. Here's an example. 3x plus 4 equals 5x plus 9. And to solve one, you get the variable to one side, then isolate it, meaning get it by itself, by using inverse operations. So basically, how do you undo subtraction or multiplication? And some problems require a few steps, while others require multiple steps. So here's three to solve. So the first one, x plus 2 equals 7. I can subtract 2 to both sides to get x equals 5. Alright, the second one, 3x minus 4 equals 5. Well, I'm actually doing the opposite of PEMDAS, so I have to add subtract first. I'm going to add 4 to both sides. I'm trying to get x by itself. Here's the x. I have to move the 3 and the 4. The 4 goes away first. Adding 4 to both sides. 3x equals 9. Now to get x by itself, I get a 3. To get a 3, that's 3 times x. I undo it by doing division. 5 by 3, 3 by 3 is 1. So that's 1x, which is x. 9 divided by 3 is 3. So there's the answer there. So box this. And then over here, I have to distribute. And only to the parentheses, not that 6. So this is 4x plus 12 plus 6 equals, I distribute over here as well. 6x plus 6. Now technically you're supposed to combine like terms on both sides separately and then solve. It'll basically turn to that middle problem. But you could move things around as long as you don't break any rules. I'm going to combine like terms on each side. So on the left side, 4x isn't combining, but this is plus 12 plus 6 combined to 18. This is 4x plus 18 equals 6x plus 6. Alright, now the variables on both sides, you gotta move to one side. Ideally, you move the smaller one. So we have 4x is smaller than 6x. So I'm going to subtract 4x both sides. That cancels out. I have 18 equals 2x plus 6. Now I got to solve for x. I got to move the 2 and the 6. The 6 goes first. I'm going to add track first. I'll divide last. This is 12 equals 2x. And then last, I can divide both sides by 2. Get 6 equals x. Alright, now you can actually check your answers. Pretty simple. All you do is plug in your answer to the original problem. So for example, this first one, if I put a 5 right here in this problem, this is 5 plus 2, the left side 7. So 5 plus 2 equals 7. Well, that combines to 7 equals 7. That's true. It's supposed to be matched on both sides. That's the check. Over here, I do the same thing. I can do 3 times 3. When you plug in for a letter, make sure you use parentheses. Minus 4 should equal 5, but we don't know that yet. So 3 times 3 is 9. Minus 4 should equal 5. We don't know that yet. Well, that is actually 5. 5 equals 5. That's true. We're good. So I do the same thing for the last one, but again, both sides, the left side and the right side should be the same if it's a solution. Alright, equations can also involve fractions. To get rid of a fraction, make sure you multiply both sides by the denominator. This can involve distributing if there's multiple terms on one side, which we'll see in a bit. And also, you can repeat this step if there are multiple different denominators, different fractions. Alright, so for the first one, x over 4 equals 10. Well, there's a fraction. I multiply both sides, this left side and this right side, by the denominator 4. Can't write there. Let me try it again. Parentheses 4. Alright, well, 4, if I multiply the left side, 4 times 1 over 4, or x over 4, cancel out the 4, so it's just x. And 4 times 10 is 40. And I can check. So that's the answer. If I can plug in, so 40 over 4 should equal 10. Well, 40 by 4 is 10, so 10 equals 10. That is true. So again, you can check your answer by plugging in. This next one, you could actually move the 2 first and then repeat the first problem. Excuse me. But we can also just use a trick. To get rid of fractions, multiply both sides by the denominator. So this left side has 2 terms. This right side has 1 term. I'm allowed to distribute this 5 to both of these. So 3x over 5 times 5 is just 3x. The bottom matches the multiply, it cancels out. Then 5 times 2 is 10. Over here, 5 times 11 is 55. Basic algebra, so solve for x, move the 3 and the 10, move the 10 first. 3x equals 45. Divide by 3. Divide by 3. X equals 15. You can play and check, but I'm right. Over here, 2 denominators, so let's do the same thing twice. So let's multiply both sides by, I'll do the bigger number first, 3. So I distribute this. X over 3 times 3 is just x. 3 times 1 over 2 is just 3x over 2. Bottom does not disappear. because the fraction's different. 3 times by 15. I'm going to do it again. So right here, let's multiply by 2, both sides. So this gives us 2x minus 3x, and now the 2's cancel, equals 2 times 15 is 30. And combine like terms here, 2x minus 3x is negative 1x, or negative x. And I want x, not negative 1x, to get rid of that number in front of x, whether it's a negative 1 or a positive, or you divide. So x equals negative 30, you can plug in and check, but I'm right. And there's also 2 other ways to do this that's slightly faster. You could multiply both sides by 6 to get rid of both the denominators at the same time, but you can do one at a time. You can also use reciprocal. There's a lot of things you can do. Just make sure you do something that's correct. And the last slide, literal equations are just equations with multiple different letters. You can't solve for a single number since terms can't combine because we don't know what the letters are. But you can solve for a variable in terms of other variables. So think of it like we're rearranging a formula. So here I have d equals 1/2 m times n plus k. We're going to solve for n. So like before, I have to get this by itself. I have to move this 1/2. I got to move this m. I got to move the k. So remember, we always abstract first. So I'm going to subtract k both sides. So now I have d minus k equals 1/2 mn. All right, I have a fraction. I need to get a fraction. After the fraction's by itself on one side, I multiply both sides of the denominator. Sometimes both sides by 2. I can distribute this. So I have 2d minus 2k equals mn. And I need n by itself, so the last thing I do, I get rid of the m. I can divide both sides by m. It cancels out. So my final answer is 2d minus 2k all over m equals n. There you go. All right, thanks for watching the video. See you in class. Make sure you ask any questions. Bye.